Apparently the program pull over. All right. Look at that. I did not hit mute this time, which is good. So won't be muted for the first portion. All right. Let's pull up Canvas here. Yeah, so Mr. D is going to be in Helsinki presenting his paper, which is super cool. This is public information, so I don't feel bad sharing that now. He put it on Twitter, not me. Just take a quick Google. I'm really bad at geography, so okay. I will trust the rest of you to answer that question. All right. Yeah, so I'll be there for lab. We'll have some fun tonight. And so we're going to move on from arrays and vectors. I'm assuming, I don't know how much of that was review. I couldn't watch anybody nod. So apologies for not being here Monday. I'm doing a lot better now. Haven't had Tylenol for like 36 hours, which is good. So feeling a little better. Why does this scroll bar not work? There it goes. It's like 3 different scroll bars right now. 1, 2, 3. This is crazy. So we're going to move on to inheritance. We're going to start this a little early, which is good. Give us a little more time because this is one of the major topics we're going to tackle, and that'll be the focus of our next individual project as well. And now that we've talked about pointers, we can see some cool stuff in inheritance as well. One of the advantages of using pointers we'll see when we start doing inheritance, which is really fun. We start up Visual Studio, start writing some code here. And maybe we can pull up our little table of contents here. So you might have talked about inheritance in 150. Is that briefly? Not at all? Did you do any code that used inheritance? Someone said yes, other people said no. Okay, so we got a mix, which is good. So the main idea here is that you are deriving your class from another one. So we're doing all of the things another class does, we're making a specialized version of it. So one of the goals with object-oriented programming is reuse. Right? It doesn't always work that way, but that's kind of the overarching goal of object-oriented programming is we make this nice little package, we've encapsulated all these details together, and now I can use that same class anywhere else I need to have that class. I don't have to reinvent the wheel. And there's all sorts of cool libraries and things we can pull up from online that people say, hey, I wrote some cool code, you can use it. Which is fantastic. Sometimes, though, it does 90% of what you want it to do, but not the rest, not that last 10%. So what we can do is we can use that as a starting point. So we don't have to reinvent the wheel, and we can specialize, make a new version of it that has those additional features here, or has whatever needs to be a little bit different. Inheritance. Can't spell this one. Inheritance. We're doing this by week or by topic? I really should. By topic. Okay, good. I'll just leave it here as inheritance then. Make sure it's in the repo. So if we have a class here, like a header file, like item. Item's a really boring example, but that's okay. It gets the job done. So a class for item here. Item has some private attributes and it has some public methods. Right, same idea. So item probably has a string in our namespace, standard string. So we have a string for the name of the item, and we have, how about a double for the price? We don't need to do anything much fancier. Oh, maybe we'll add a quantity as well. Right? So you could buy like 3 of these items, or 10 of these items, or if you're buying ramen noodles, you buy them in cases of 12. Which, if you buy the case of 12, you can scan the single barcode. But if you buy like 11, you have to scan 11 individually, which is really obnoxious. Seems like that should be like a quantity thing on these UScan machines, but apparently they don't trust us to be our own cashier, but they still want us to be our own cashier because it's cheaper. So I don't know. It wastes our time, which is free for them. So quantity. Okay. So things about item then. The name probably never changes, right? Otherwise, it's a different item. The price is going to change, right? Stores like to change the price of things. They go up, they go down. They say, hey, look, it's on sale, and it costs like a penny less than it used to, but then they're like, look, it's on sale. Technically, everything in the store is on sale. If it's not on sale, they don't sell it to you. So, like, saying something on sale is a silly misnomer here. So if you like to argue about technical meanings of words, software is a good field for you. Don't argue with people. I'm sorry. It's just entertaining sometimes. So if we want to write a constructor for item, right, we probably need to know the name. We could take a price, or we could make price optional if we wanted. I don't recommend price be optional though, because if you leave it optional and then you forget to go change it later, now you're giving these things away for free. So that's probably no good here. So we probably want a double for price. Now quantity, we can probably default to just 1. So if you don't tell me how many you want, we'll assume it's 1, right? That's probably pretty safe. So then I can set my name as the name. We can set my price to the price. And we can set my quantity to the quantity. Right, nothing super interesting here so far. Bunch of get methods, so we can get these things, some set methods. Again, price should probably never be negative. We should do some sort of checking on that. Right? A negative price is really bad if someone goes to UScan and starts making money every time they scan this item. Right? As you can imagine, bad things would happen. And generally, when it comes to data entry, the people who do data entry are not your highest paid employees. And I don't know if we talked about this before. I like to ramble a lot. I apologize, but sometimes it's interesting. The amount of effort that people are going to put into their work generally corresponds to how much they're getting paid to care. So if you're paying someone not very much money to do data entry and they mistype something, too bad. Like, they're not going to go fix it. That's why hospitals are particularly bad at this. The admissions clerks who have to take your name and information down to see, do you already have a record at the hospital here? They're really bad at that. So one of my kids has 3 different records at the hospital. I had to get merged recently. Like, Sobol-Chernesky is a really unique last name. I don't know how they screwed that up so bad. But they did somehow. And so it didn't pull her allergies on file because it didn't match up with her previous record. And then when they asked me, does she have any allergies? I'm like, I got 7 kids now. I don't remember. Which, I'm a terrible. Okay. It's not the worst. She doesn't like artificial colors, like make her throw up. So it's not going to kill her if they give her medicine with colors in it. So it's not like the penicillin. I remember my daughter who's allergic to penicillin. That one I do remember. But so we should write some get methods, some set methods. Hector, my friend, thank you so much for donating some bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. I've had a lot of coffee already this morning, and I've got more in the car. I didn't bring in the second mug, but I do have a refill. I'm very excited. All right, so string for get name returns this name, a double for get price. These ones are boring. I don't even know. It's probably still good practice, right, to be writing these out here until you get real comfortable with classes. And for get quantity, return this quantity. Right, now some sets. So we said we're not going to change name. Right, so name is essentially read only. We're going to set it in the constructor and it's going to be stuck. We're not going to let you go change it. So there's no set for name. We do want to be able to change the price. We do want to be able to change the quantity. So we can have a void for set price, give it an int for price. And again, we want to do some sort of sanity checking. Right? We want to make sure the price is valid here. So if price is less than or equal, even 0 is a bad price. Right? We shouldn't give things away for free, especially not negative. I'm going to throw, what do we have? There was I remember the error we used. Logic error? Yeah, logic error. Price can't be less than or equal to 0. That sounds right. And yep, we just can include our standard exceptions. Fantastic. I love when it writes code for me. I don't want to have to go write it myself because I can never remember what it is here. So if it's bad, throw that exception. Otherwise, we can set my price to the price. Right? It's probably same idea with set quantity, right? Quantity, give it an int. Oh, that should be a double for price, shouldn't it? Double for price, an int for quantity. Right? We can check, make sure we don't have 0 or less. You can't, like, why would you buy 0 or less? Quantity can't be less than or equal to 0. Otherwise, we'll set our quantity. And now I already have this code here. I don't want to have to repeat myself in the constructor, right? So we're going to change these to use our methods, our functions. They will do the sanity checking for us. We can call set price given the price, and we can call set quantity given the quantity, right? That way we can get that sanity checking done as well. So you can't get an object in a bad state. One of the jobs of our class is to make sure it has integrity. The class shouldn't let itself be put in a bad state, because we're going to rely on these numbers, these values. And again, this one is not the most interesting example, but we need to rely on these to make sure they're accurate. Now, the last thing that we can do, which can be useful here, is we can get a total price, which is your price times the quantity. So if you say, I want to buy 10 ramen noodles at 39 cents a pack, we know, okay, it's $3.90. Sure. So we can do that arithmetic for you. So we'll have a get total price function here, and we can return this price times this quantity, right? So you want to buy that many of them, they cost this much, great, we'll go for it. Here's your total price. All right, now we have item. Sorry, that wasn't too bad. Now imagine we wanted to have a store and we wanted to have a bunch of these items, but the problem is in the state of Michigan, you have to charge tax on some items. There's a sales tax. Actually, on most items, get sales tax. The minority of items don't have sales tax, which whole other reasons. But I don't want to have to redo all of this, but I can't just use item, right? Because I'm not tracking the tax. So what we can do is we can make a specialized version of item. Right? We can do all the things item does, and then add that functionality that we want here. So I can add another class here for, say, a taxable item. And we want, this is a taxable item here, and we want to include our item class here, because we want to do all the things item does. We want to inherit or derive from. There's like 3 different sets of terms for this. I don't know why there's so many different terms. Some people will say there is a superclass and a subclass. The superclass being the base class and the derived class being the subclass. So if you derive from something, you're the subclass, or a parent and child relationship, you have a parent class and a child class. If we think of these things with inheritance, and I'm going to just cheat here, go back to the book real quick and make sure I remember the syntax. Never remember. There, colon, easy. So we'll say I'm a class taxable item, colon. Now, you can specify what level of inheritance you get. This one is a little silly. Usually we just want the public stuff, right? Public item. So I can say, hey, I am an item. I'm taking all the public things from item as part of my class. So we've created this is a relationship. So a taxable item is an item, right? A lot of folks have taken biology, and we talk about this hierarchy of how we classify things in biology. And there's kingdom, phylum, class, order, family, genus, species. I don't know why that's in my head still, but that one stuck for I don't know why. But right, one of the is it a class? I believe is Mammalia. If you're a bio major, I apologize. I'm probably butchering it here. I'm just doing my best. So there are lots of animals that are mammals, right? But there are special types of mammals like humans or like dogs or like cats. We're all mammals, but we're special types. So that's the same kind of idea with inheritance. We all have this common set of features of mammals that we all share. Then we have special things that make us a unique species inside of that class. So same idea here. So we will be an item, but we're going to have special features, special things that make us distinct from just a generic item here. So with the taxable item, we're probably going to have private and public. We're going to have a double for the tax rate here. So how much do we need to charge in tax now that we're a taxable item? That's really the only thing that's going to be different right now. Not the most interesting thing here. And then we need a way to get that value, to set that value, to have a constructor, right, to do all these sorts of things here. So we can make a taxable item constructor. Now, if my item class, my parent class, my base class, my superclass here has a constructor that takes arguments, I have to call this constructor. If there's a default constructor that takes no arguments, it'll happen automatically. Right? So if we just let C++ give us the default constructor, we don't have to worry about it, aside from the fact that default constructors are usually bad, and we probably shouldn't have them anyway. but it would get called automatically. If we write our own default constructor, that one could get called automatically. That's great, but then you've got a blank name, and what are you going to put? Nothing on your shelf? Right? Your store won't be very successful if you don't sell things. So we need to make sure we're going to call that constructor. So to be able to call that constructor, I need all of these arguments, right, so that I can pass them to that constructor. So my taxable item needs all of these values here, so I can pass them to the item constructor. And then I also need my tax rate. So having the optional argument, remember those have to go at the end, which is a little bit of a bummer. So I'm going to be a different order now. So if I want a double for tax rate in here, then I can have the optional quantity. We can do that. And the optionals have to be at the end. So my order will be a little funny here, and I can bump that down a little bit if you want to see. That's a little cleaner here. Then we need to call our constructor. I can never remember the syntax for this one. Where'd it go? I think it's like a colon. Base? No. Oh my goodness. Help me out, Zybooks. No. This one? Oh, it was colon, right? Colon item. There we go. Thank you. Syntax always gets me here. There's too many different ways to do this. So we'll say, hey, when you call me, so same idea with this colon notation. I am a type of item. When you call this constructor, call the item constructor, name, price, and quantity. So that constructor will just pass through the values, essentially. Put that back on that line. It's a little long here. Again, I can bump that down, I think. Sorry, I'm zoomed in quite a lot, so it shows up decently on the recordings and stuff. So we have our own set of arguments, which are going to include all the arguments that my superclass needs, my base class needs. I'll give those to the base class constructor. This is going to happen first, then my constructor code will run. So when we run this in debug mode, we'll see it step into the item class constructor, which is super handy. And then we can set this tax rate to the tax rate. And again, we probably want some sort of sanity checking on tax rate here, because when you ask people for tax rates and you say, hey, what's the tax rate in Michigan? If they say 6%, now you and I know that's 0.06. But most people, if you say like enter the tax rate, I'm going to put in the number 6, meaning 6%. But 6 and 0.06 are wildly different numbers. You don't want 600% tax, right? That'd be no good. But if they do enter 0.06, we don't want to have to divide that by 100 and now have 6/10,000th of a percent or whatever. So we don't want the wrong amount of tax. So setting the tax rate is important. So a set tax rate given a double for tax rate. We want to do some sort of sanity checking here. Now, again, negative is no good. There are no rebates here. I don't know of anybody that does that, at least with a sales tax. Now, their tax system might send you rebates when you file taxes at the end of the year. That's a whole other tax policy story. But at the grocery store, at least, they're not giving you money back on these taxes. So we can check first to see, hey, if the tax rate is less than or equal to 0, maybe even okay. But why would we have 0 if this is a taxable item? So we'll probably say 0 is no good here. Right, so we can throw a logic error. Tax rate can't be less than or equal to 0. Right? Otherwise, then I'm going to do some sanity checking here because I want it to be between 0 and 1. Right? I want it as the decimal notation. So I can say if tax rate is less than 1, then great. Let's go ahead and we'll just set it. We'll set tax rate, this tax rate equal to the tax rate. Okay. If it's not, then, right? So I know not less than or equal to 0. If it's not less than 1, it means it's more than 1. I'm going to set my tax rate to the tax rate divided by 100 because I'm going to assume they probably gave me 6 instead of 6%. Right? Again, this is possibly a risky assumption here, but we're just doing an example here. Data validation is hard sometimes. And this way, you can give me 6, you can give me 0.06, and you should get the same result. Right? Okay, and this is one of these will run here, right, with this if-else block. Either we throw the exception or we go and set it. Right, so we can set the tax rate. Again, we should just use that function here. Set the tax rate, given the tax rate. Then we need a get tax rate, a double for get tax rate here, given the return this tax rate. Okay, it's all well and good. Now, the last thing we want to do is we need to be able to get the total price. Just like item did, we need a get total price here. So what we're going to do when we write this method here, we're going to specify that we want to override and change our parent class's behavior. So we're going to say, hey, I don't want to do the thing item does. I want to do a different thing than item. We're going to override. Override? Oh, so if we're going to let this one be overridden in this class, we have to mark it, which is obnoxious. So we need to mark this method to say, hey, I know someone can go and change this behavior later. I think we're going to mark this one as virtual. That sounds right. So if I mark this one as virtual, then later I can go and override that method here for double get total price. Give me over. Oh my goodness. C++, you're killing me. Virtual function. Is it just if I mark it virtual? Damn. That's obnoxious. But okay. So you've got to set it in your parent class. Mark it as virtual. Okay, sure. Why not? So I want to get the total price here with the tax rate. So I need to get my item class's total price. Right? I could ask for this total price if I wanted this one. Otherwise, I have to do the same arithmetic twice. And this is sometimes these functions get a little more difficult than just some quick arithmetic. So if I wanted items version here, let's try and find it's where is it here? I want to steal all their examples. Where'd it go here? Keep description. Oh, it's not doing it. Yeah, that's fine. I think is it just item, get total price? I think that'll do it for us. So we'll get the items version of get total price to say, hey, I want this one because my parent class already has all this logic built in. Then I just want to go and add the tax rate. Actually, that'd be like plus. Here, right? This would be this tax rate times the total price. Or maybe we'll just multiply by 1 plus this tax rate. There we go. That's probably a little nicer. And we don't have to get total price twice. Right? So get the total price for my parent class, my superclass, then multiply by 1 plus the tax rate. So 1.06 will give me the final total price here, given this get total price function. Nothing new yet? We still in boring review? I'm sorry. We're getting there. Okay. Then what we can do now, this is where it gets finally fun. So we'll add our source file here, not a header file. That was the wrong one. Add source file. There we go. All right, so we'll include stream standard. All right, so if I want to include then my item class and I want to include my taxable item class, here I can make items and I can make taxable items. Finally, the fun stuff, right? So let's make an item. So we'll have and now I'm going to use regular objects first, and then we're going to use pointers next. Because you might have seen what the fun stuff that pointers do, but that's the fun stuff. So I make an item. What do we have? So something that is not taxable is going to be like fresh fruit, right? like apples, maybe apples, and they're way too expensive nowadays. What are they, like $1.99 each or something? Depends what kind of apples you get. Or maybe $1.25 each. And let's buy like 3 apples. Sure. So we can see out your total cost for apples is, and then we can add in my apples dot get total cost, total price. Okay, and then we'll do a taxable item. So we'll have a taxable item. Now something that's taxable then is going to be prepared, or no, anything other than fresh food, basically, I think. Right? Is it just the fresh food that's not taxable? It's been a while. So what sounds good for lunch? Chicken nuggets. Chicken nuggets. All right, and so chicken nuggets. And how much do those cost at Meyer? Those are pretty cheap, right? We're gonna get a big frozen bag of them, $1.99 or something. And we'll just need 1 bag here to microwave. Okay, and then we'll get the price for that. Get total price. Should add the tax rate. Oh, that's right. We need to give it the tax rate. This is going to be, that's the wrong constructor. So we want 0.06 for the tax rate. And then the quantity was optional. Right? So we can leave off quantity if we just want one of them.
Also change this.
Oh, yeah, thank you. We could even do like get name, right? That fancy? Get name. All right, now I feel bad we've got the same code in here twice, right? Basically doing the same thing twice. But I can't write a function very easily that says, hey, take this or take this. We'll get there. We'll get there. All right, so let's just make sure it works. We get our total price out. Uh-oh. Yeah. Oh, that was the wrong button. You want to say no there. That's not going to work. Build errors. Get total price. Oh, we should return that, shouldn't we? See if that works. Okay, so apples, $3.75, right? So that is $1.25 times 3, right? And then chicken nuggets, looks like we added 6% to 1.99. Okay, and the rounding here is a little rough, but that's okay. Would have expected that to round up, but okay. We didn't specify rounding, so no big deal. So working so far. All right, but we don't have, it'd be nice if we could have like some sort of function like print item cost or something that takes an item. Because that would be a lot easier. We could have for and then do item.getName is, and then item here, item, get total price. Right? If I could just say now I want to print item cost. Come on, give me my function. Given the apples, that'd be nice. But now for chicken nuggets, here I want to print my item cost. Given chicken nuggets, oh, it fits. It's not yelling at me yet. I don't get the right price for chicken nuggets though. It fits. It is an item. So C++ is going to say, oh, sure, you are an item. You look like an item. You have all the right functions for item. But the problem when I pass it now, it doesn't do my taxable item functions. Because we've passed it as an item. That's no fun. But if we were to take an item pointer here and make these pointers, item pointer apples equals new item, and a taxable item pointer chicken nuggets equals a new taxable item. When I pass my pointers here, so item get name, why do we have to change the notation? I'll never know. I didn't write it. It drives me nuts. Now, just by changing that to a pointer, I do get the right version. This is where everyone's supposed to be like, ooh and ah. This is like magic here. Thank you. Yes. Yeah. Ooh, ah. Exactly. So what's happening here is we specified an item pointer, but at runtime, while the program is running, C++ says, oh, well, I know you're an item pointer, but what are you really? And it's going to say, oh, really, you're a taxable item. We will run your overridden version of that function. Even though we're treating you like an item, we're going to run the correct version of this function. This is where it gets crazy. So if we do all the right things, we mark these as virtual, we do these things. So, and we technically, if we don't mark it as virtual here, C++ is okay with that. But now when I run it, I don't get that behavior. So we need that keyword there to say, hey, you might get a new version here. You might get a special version of this function here. So having that keyword virtual here is important. So I usually put it on this side. Okay, C++. So if we deal with pointers and are using our dynamic memory here, at runtime, C++ can figure out which version it should use, even though it looks like an item. Now, it doesn't work for new things, right? If I were to go add a new method that's not overriding a virtual method, that's not going to work because it can only do the things in item, right? Our function says, hey, I'm going to treat this like an item, so the only things we have access to are the functions in item. So, but if we've marked them as overridable, great, we can go and get the specialized version of our subclass of the derived class. That's where all the magic happens, but we have to be using pointers for that to work for reasons. C++ is weird. That's one of the reasons we start with pointers. So what's cool here is then I don't have to really care if someone else goes and specializes item, right? I can write item and I can write a whole set of things to deal with items in my inventory management system. Say, hey, cash register, just get the total price from item here. And later on, if someone wants to go implement taxable items, my cash register doesn't have to change, right? It still says, okay, hey, take the item pointer, get the total cost. It will do the right thing, right? The next thing we can do, we can add another class here. And this one's a little bit fun as another header file. This will be a, what do they call these? Perishable item, items that go bad, right? That we can't keep on the shelves for too long here. So we'll include my item class, and we want a class for perishable item that will be a type of item. Excuse me. And we'll have our private variables, we'll have our public functions. Now, perishable item, dealing with dates is the worst thing in the world. So I'm going to cheat here and not use actual dates because actually dealing with dates is really hard and difficult, and we just are not going to bother spending the time on it right now. So we're just going to have something like an int for days until expiration. Okay, and I'm just going to leave it at that. Is that all right? Because I don't want us to do the rest of it here. Okay, and then our constructor then will take a perishable item. Now we need all the things for item, right, to be able to call our constructor here. And then I'm going to have another int for days until expiration here. So I'll pass in days until expiration and the quantity, and then we'll send all of those to the item constructor, the name, the price, the quantity, make sure that constructor is happy, and then we can set my days until expiration. Again, maybe do some sort of sanity checking here, but it is possible for this value to be negative, right? You've got mangoes on the shelf there that should have been sold by yesterday. They're now expired, right? They're getting real soggy and gross on your shelf there, and that's pretty sad. Now, it's a little harder to tell with mangoes, and sometimes Meyer will keep them on the shelf longer than they should, right? But things like bread, they've got to take off their shelves because they have a printed date on them. Mangoes don't have a printed sell-by date on them, right? That's up to you. If you buy a rotten mango because you didn't check it here, that's your own fault, I guess. So, but things that have dates, they actually do have to take off their shelves. Okay, so what we want to do here then is we're going to change that behavior for the get total price. So our double get total price, I want to get items total price here. We'll get the double for total price is my item classes get total price. Then I want to check, hey, if the days until expiration is less than or equal to, what do we want to say? If it's like a day away, how about we return total price times 0.5? We'll give you half off. Or we could do some sort of sliding scale, right? If it's like 2 days away from expiration, we'll give you 75% off. Let's do that. If it's 2 days, we'll give you 75% off. Else, if it's 1 day away from expiration, we'll return total price, give you half off. And then if it's less than or equal to 0, should we just give it away for free? I mean, we technically can't sell it at that point, right? So maybe we just return 0. Like, you can just have it. We're not allowed to sell it. And if we haven't done any of those, then we can just return total price. Right? So either you get the discount for 2 or 1 or past sell by date, or you get the regular price. Right? So same idea now. I can use perishable items. I've now been able to implement that code, and my register doesn't need to do anything different. Right? It still says, hey, give me that item pointer. I'll get the total price out. If we've gone through and set all these things in our system, great, now we know what the dates are. Right? And it will just work for us. Now, probably doesn't actually work like this in stores, so they have to put like separate barcodes on things for discounts because the barcode doesn't change, or barcode doesn't have the expiration date. But if they ever did that, they'd save themselves so much time, like to not have to go put those stupid stickers on. But apparently people like those orange stickers, and you see the orange sticker, you're like, hey, I'm getting a deal. You know, it might be a little iffy for these bakery products here, but you know, I'm going to eat them tonight because I'm really hungry. I'll just go buy a dozen cookies and eat them all at once and then feel bad about myself. I don't ever do that. Yeah. It's really bad if you're diabetic too, but that's okay. It just take a lot of insulin. So we can do perishable items, right? Perishable item. Oh, we got to include that. Perishable item. So if I want a perishable item, what do we? And we'll use the pointer here for this, right? How about that's cookies equals a new perishable item. And these are double chocolate chunk is a really good one. Yes, double chocolate chunk. And those they're usually like $2.99 for a dozen of them here, which is not too bad here. But if you can get them half off, that feels good. Right? So we'll say 1 day until expiration here, and I only need 1 box of them because more than one is going to kill me. And then we can print the item cost here for cookies. Again, you won't be surprised, but we'll get half off our price here. Right? We get half off the $1.99 without having to change any of the rest of our register code. Yeah, is that a question?
Yeah, so like at the principal, I don't have like the days until expired or whatever. Like 2 days, how would accept 2 days?
Yeah, we need that. So you're right. So we need a way to change that days until expiration. So either we let someone go in and say, okay, this is your new days until expiration, or we can have a method like subtract day or add a day or next day, I mean, anything we want to call it here that just takes 1 day away from that day that expired. What do we want to call it? I think it's probably easier to do that than a set value, because then you have to like get the value. We never actually wrote a get, did we? Int get days until expiration, earn this days until expiration, and then how about just a pass a day or something next day. This days until expiration minus. Let's take it down by 1. Right? We should be able to change these things. That's right, because otherwise we're going to sell old food and then we're going to get in trouble. Here, there's something about like dented cans too. Grocery stores have some really weird rules here, which I think are all food safety related. Right? We don't want grocery stores making us sick. Apparently that was a thing in the past, but I don't know. Meijer does a decent job, I feel like, of that sort of thing, but who knows? Which I'm really sad though. They're no longer going to be 24-hour stores. It's really nice to shop at 1 in the morning when the rest of you people aren't there. I've asked, and all the management says they're not. They're never going back.
They changed it to COVID.
Yeah. So the one manager I talked to, because I'm a curious person, was like, we haven't seen our total sales drop, so there's no reason to open it back up.
Yeah, anytime I would go there like 2 in the morning.
Yep. Yeah, I mean, I like shopping in the middle of the night, and it's obnoxious to have to get there before midnight. And then apparently they make their registers turn off at midnight, and they can't do transactions after midnight. So like they're like, bring your stuff to the front. No, like the self use cams turn off, and you can't check out after midnight. They're like, sorry, you took too long. Like, that's one way to get people out, I guess. I don't know, I've always been a night person. I really like the quiet middle of the night. It's just much more peaceful. I don't like dealing with people. I don't want to have to deal with all the Karens in the store. They're just they're draining. Just even just watching someone else get yelled at makes me feel bad. Like, go get a hobby. Do something. These people don't get paid enough to listen to you. I don't know. Just a little bit of kindness really goes a long way in the world. So strongly recommend kindness. All right. So for inheritance, then let's see if we hit a lot of these things on our hit list. I haven't done it all yet. Overrode. Yes, this is so. Our technical term for this is polymorphism. That's generally another fundamental of object-oriented programming. So we'll talk about inheritance, talk about abstraction, encapsulation, and polymorphism. So polymorphism and inheritance kind of go hand in hand here, in that we can treat your child classes, your derived classes, your subclasses as their parent types, as their base types here. And that works with virtual. Okay. Now we haven't got to the abstract classes. We could start them here, but I don't think we have got quite enough time. And then we're also going to talk about UML as well, which is great. So not this lab, but next lab, we can talk about UML, and you can write some pretty pictures here and use Visio, which is a really nice tool for it. There's some online tools which are great. I do it in Word because I'm lazy, and it works about the same. Most of the time, I don't need any super fancy drawings. But we'll get into some of that as well. Let's see. So topic-wise, yeah, awesome. So we're going ahead, which is good. So we are wrapping this one up. We can finish this on Monday. We'll have time for Project Zero on Wednesday. How's the project going? You guys all started, right?
Yeah.
Yes, thank you. Because I'm going to have limited availability to help you if you wait until the last day, right? I get it. I do the same thing with my deadlines. It's not due for 2 weeks. I'm going to forget about it until like the day before it's due. It's bad for you and it's bad for me. And I'm going to feel bad if I can't help you. And then you're going to feel bad because I'm not helping you. I'm like, look, it's due like, in 24 hours or something. We can meet. Maybe I can make room for a couple meetings, but generally it goes better if you start earlier and ask me questions earlier. And I wrote this nonsense assignment myself. Like you saw me write it. So if you have questions about it, like if it doesn't make sense, please ask me, because it probably doesn't make sense to someone else either. So you're doing all of us a favor by clarifying what did Eric really mean. Okay, so happy to answer questions. If you get stuck on it, again, my general rule of thumb is you work a good 30 minutes to an hour trying to get unstuck yourself. That's a good life skill. In the professional world, you will do this all the time. Like, I don't know what's going on. I'm going to bang my head against the wall, try a couple things for a little while. It's not working. Okay, let me go ask someone else. Right? When we hire junior developers, we don't expect them to know everything. Who knew? Right? Because you're a junior developer. You don't have that experience. So what you want to do when you come and ask for help from your mentor or whoever you're teamed with, or a senior developer, like, okay, I've tried these things. This is my process, what I've worked through already. I don't know what to check next. Right? You don't just be like, oh, hey, I don't know what to do. Right? You want to come with, okay, I've tried these things. This is what I've looked at already. It's going to speed up their time, and it's going to show them you're not just an idiot. Like you haven't seen this thing before, and that's okay. Right? And then they can help you through it. So, give it a good try, 30 minutes, an hour, and then just reach out to me and ask for help. Most of the time, I can get you pointed in the right direction in about 5 minutes or less. Right? It's if there's some syntax that's catching you somewhere or given some sort of errors here, the red lines in Visual Studio are only so helpful, right? Usually they're decent, and the more you read them, you'll understand what they mean here. But I can usually point you in the right direction pretty easily. So come and ask for help. I'm happy to do that for the projects. I'm not going to tell you to go away just because it's a project, right? I want you folks to be successful. That's literally why they pay me, not just to have someone talk at you, because you could just go watch YouTube for that, right? Which actually is kind of a good model. Like watch a bunch of YouTube videos and then come to class to do the practice where you can ask questions of somebody. We're working on that more in Math Land. Some of the math folks I talk with have like all their lectures recorded, and that's what you do for homework, is watch that, and then you actually do the homework in class where they can answer questions. It's a really cool model. We're not quite there yet, and then it doesn't work well if people don't watch the videos, because then they have no idea what's happening. So there's no like perfect way of doing this, but they pay me to answer your questions, really. So happy to do that on the project. So let's do 1 week from today. We still got a decent amount of time, 11 a.m. So in class at 11 a.m., I'll go over my solution. Once I've shown a solution, I'm not going to take it from you anymore, right? So these have to be in on time. You know, I could be a little flexible with the quizzes. Mr. Dia seems to be pretty flexible with the labs, especially if you're sick. That's okay. Like those are meant for your practice. If you get behind on those sorts of things, it's not good for you, right? You want to get caught back up and not have a pile of it to do at the end. But in general, that's great. Ooh, someone on Twitch wants a dad joke. So if you watch, you get channel points. It's a fun little interaction thing. And for Christmas, I got this wonderful pack here of dad jokes. So if you're ever bored and just it's really hard to like stay focused for a long time on topics that are really technical, happy to interrupt with some nonsense here. So I used to have a job at the calendar factory, but I got the sack because I took a couple days off. That's a pretty good one. Some of these are not very good, which I think is part of the idea of a dad joke, right? It's supposed to be bad, but you want a decent pun here. All right, fantastic. So I think we're pretty good for today then. So we'll meet up in lab tonight, and we're going to work on what else do we have here? So we did classes and we did unit testing with the most recent lab, right? So we still need to talk about exceptions and pointers and arrays and vectors. And I think that'll get us caught up to date. Most of what we were doing with pointers was using the dynamic memory for arrays so far, right? I should have done some pointers before, and now we're seeing pointers with inheritance. That should get us through all the stuff we need to do with pointers, and we'll be pretty good there. So we'll practice some exceptions, we'll practice some pointers, making those dynamic arrays. We'll have a lot of fun, okay? All right, folks, I will see you tonight then. Thanks, everybody. When does a joke become a dad joke? When it becomes apparent. Thanks, SWK. That's solid.